Reading calculus. Here we go. Consider the following problem. Length S of t of the side of the base of a square prism. Whoa. The side of the base of a square... Okay, hold on. What's a square prism look like? This is a square prism. Here we go. All right. Get my marker here. All right. Okay, imagine those are all equal. Actually, we'll go like this. All right. There's our square prism. I'll do the dotted lines for the sides that you can't see in the back. Okay, there's our square prism. One of the sides is S, and it's a function of t. Is that what it says? T, yeah. S is a function of t. Got it. That's what it says so far. It is decreasing at a rate. Whoa, whoa, whoa. Guys, this is calculus. Whenever you see the word rate, you must pause and acknowledge the rate. Okay, it says rate. Okay, this 7 is a derivative. It's a slope of something. What is it a slope of? It's a slope of the S I was talking about earlier. So this means that ds over dt equals 7 in this problem. At this t, it equals 7. We can also say S prime of something, but I don't know what that something is, but we know that it's 7. That's the rate. Okay, so far so good. Next one. It says kilometers per minute. Oh, we should probably do that. Kilo per minute. Okay, kilometers per minute. And the height, that's an h of t, is a prism of the prism is increasing at a rate of 10. Oh shoot, I already made a mistake. I just saw the word increasing and I'm like, why do we need to know that? The other one said decreasing. What does that mean about the 7? It's a negative. It's decreasing. Oh, h is right here is your height, and it's also a function of t. We can say h prime of something, or you can say dh over dt. Those are just the two different notations. The primes, these are Newton's notation. These are Leibniz notations. Okay, they're the same. This one's 10, and because it says whatchamacallit, it's increasing. We're gonna keep that as positive. What's the units there? It's kilometers per minute. Same thing as the other one. Kilo per minute. Okay, so what about the rest of the problem? At a certain instant, t naught, the base's side is 4 kilometers. Ooh, t naught. So the base's side, so t naught, I got to put the naught right there. What is it? It's 4? The length is 4. That means each of these is 4. Okay, then it says that the height is 9. So at t naught, the height is 9. And I think that's it. What is the rate of change of the surface area? Oh, we have a whole new number. This capital A right here. What is the surface area of the prism at that instant? Now, we could find the surface area at that instant. The rate of the surface area at that instant. But I don't think that's what the problem wants us to do. It says match the expression with its given value. So we got to look at each of these and match it to one of these numbers that are given. I see -7, 4, 9, and 10 all inside this description. Now, what is dA dt? What the heck is that? That's the rate of change for the A. Okay, so if we took the derivative of this, we would get dA dt. Do we know what dA dt is in this problem? Not, dog. It says, what is the rate of change of the surface area? It is looking for that. So we do not know that one. That one is not given. Do we know the number for the rate of change of the height? That's 10. Now, I took the time to write it all out. You guys probably won't do that, but I'm teaching you. I guess you're not. What is this one? What does the S prime mean? What is that? That was -7. What does that mean, though? That's the rate of change of this side. So the side is going down from 4. So it's no longer going to be 4. It's going to be less than 4 because it says it's decreasing. And we know that to be -7. Okay, so this problem is done, but I'm gonna solve it all the way. Okay, you guys ready for this?
The answer is 4.
Okay, so what we have to do first is we have to find the relating equation. Now, this type of problem kind of hints at you what the relating equation is. It says the surface area. A is the surface area. So let's write an equation for the surface area. Do you guys remember surface area from geometry? Here we have a square on the bottom and a square on the top. Let's talk about those guys first. There's 2 of them. So I'm going to say 2 times, and then what would I have to multiply to 2? How do you find the area of the squares? Wouldn't it be side times side? Yeah. So I'm going to say s squared. Okay, so that's an s squared times 2 because there's a base and there's a top. Plus, now we have to add together all the areas of the sides. Here's a side right here. How do we find the area of this side right here, Stews? Don't take too long to answer. H times S. So HS. Are you guys good? How many of those sides do we have? There's 4. Cool. You're done. That's how you find the surface area. Now, how do we find dA dt? You take the derivative of this with respect to t. What is the derivative of a? It is dA dt. Done. What is the derivative of s squared? Or 2s squared? It'd be 4s ds dt. You guys still with me? All right, because it's going to get sloppy here. We have s and h multiplying to each other, so we're going to have to use the product rule. So I have 4h. What is the derivative of 4h? It is 4 dh dt. And then I have to multiply that times s. Plus, what is the derivative of the other one? 8, or s. What is the derivative of s? That is ds dt. Now we're just about done. Now the question wants us to find this. The rate at which the surface area is changing. In order to do that, I need 1, 2, 3, 4, 5, and 6 numbers. Do I have all of those numbers in this problem? Are they all there? Yeah. All right, tell me what the S is. What's S? Nah, it's 4. It's right here. It's right here. That's S. What is ds dt? Negative 7. Plus 4. What is dH dt?
10.
Oh, that's 10. And what is S? 4 plus 4. What is H? 9. And what's ds dt? ds dt. Negative 7. And so I'm not going to finish it because I'm being lazy right now. But all you'd have to do is you'd have to multiply all those numbers, add them together, and then you find your dA dt. Yay! Related rate problems.